This is example 7.5 from Discovering Design with Chemistry. Aluminum carbide, Al4C3, reacts with hydrogen monochloride according to the following balanced equation. So here's our aluminum carbide and here's our hydrogen monochloride, and they've already balanced the equation for us. It produces CH4 and AlC3. If 83.1 moles of AlC3, so we have 83.1 moles of that, are reacted with an excess of hydrogen monochloride. So this one has excess. In other words, we're going to have leftover of that at the end of our reaction, which means we're using all of the Al4C3. That was the purpose in them telling you that there was an excess of one, so that you're aware that we're using all 83.1 moles. And they want to know how many moles of CH4 and AlC3 are made. Okay, so let's start with making some conversion relationships. So we can imagine there being a 1 here. So for every 1 mole of Al4C3, there are 3 moles of CH4. And for every 1 mole of Al4C3, there are 4 moles of AlCl3. So that's our conversion relationship. Those are the only two they ask about. Yes. Okay. So we used 83.1 moles of Al4C3, and we want to know how many moles of CH4 are going to be made. So that's what we're going for first. So we're going to multiply this by something so that we find the moles of CH4, and we want to get rid of the moles in Al4C3. So of these two relationships up here, this one is a very messy one. Let me rewrite that A. All right, so this one has Al4C3 and CH4, so we can write in what we have here. So for every 1 mole of Al4C3, we have 3 moles of CH4. So we can just multiply that out, and we have to remember that we need to keep 3 significant figures because that's how many we have in 83.1. So we get 249.3, but we can only keep 3 significant digits, and the 0.3 makes us round that down to just 249. So we have 249 moles of CH4. Let's make that look better. All right, so there's our first one. And then our second one wants to know how many of AlC3 are made. That can use our second one. So again, we're going to start with the same 83.1 moles of Al4C3 that we know about, and we're going to use a conversion relationship because we know that for every Al4C3, for every 1 mole of Al4C3, we have 4 moles of AlCl3, because that's what this conversion relationship tells us. Again, we get to cancel out this because we set it up that way, and then we can just use our calculator. Again, we have to remember that the 83, oops, I realized I forgot to put my point there. The 83.1 has 3 significant digits, so we have to keep 3 significant digits in our answer. So we have 332.4, but we can only keep the first 3 digits, so 332 moles of AlCl3. All right. Let's see if we had anything else. Did this one? All right. So in the example, it points out the problem did not ask for anything extra, but it it says that we could have also figured out how many moles of HCl there were. And we can do that by creating yet another relationship. So for every 1 mole of this, we have 12 moles of this. And so 1 mole of Al4C3 in this particular equation or chemical formula is going to be able to, sorry, I can't talk right. So for every 1 mole of Al4C3, we will get, or we also need 12 moles of HCl. And so we can use the same 83.1. Oh, I did it again. 83.1. The same moles that we had before of Al4C3. And we can figure out how many moles of HCl we had by using this conversion relationship. So Al4C3 and moles HCl. So for every 1 mole of Al4C3, we have 12 moles of HCl, again, because we're using this conversion relationship that we made using the reaction formula that was up there. Zoom out a little bit so you can see all of it. And then this will cancel, leaving us with what we actually want, which is the number of moles of HCl. Again, let's use our calculator real quick. And we need to remember that we have 3 significant digits that we're working with. So 83.1 times 12 gives us 997.2. We only need 3 of those digits because only 3 are significant, so 997. So again, we didn't really need to do that, and we know that we had that in excess, so we only, in the reaction, we would only use 997 moles of the HCl in the reaction with the 83.1 moles of Al4C3. But because it's excess, we would have had extra moles in the process that were left over. But that's how many we would have used. All right.